Capacitors C1 is equal to 4 microfarad and C2 is equal to 2 microfarad are charged to the same potential 500 volt, but with the opposite polarity as shown in the figure. The switches S1 and S2 are closed. We have to first find out the potential difference, okay, between the capacitors, and second thing we have to find out is the ratio of the final to the initial energy. If I connect the capacitors in the opposite direction, okay, let me say that the initial charge on the first capacitor is equal to Q1 and the second charge is equal to Q2 before the charges are transferred from the first capacitor to the other. Now Q1 is equal to C1 into V1, which is equal to 4 microfarad into 500, okay, 4 into 4 microfarad into 500, which will be equal to 2 into 10 raised to minus 3 coulomb, okay, which is equal to 2 into 10 raised to minus 3 coulomb, okay, and Q2 will be equal to, similarly it will be equal to C2 into V2, which will be equal to, this is half of the capacitance, so it will be equal to 1 into 10 raised to minus 3 coulomb, okay. Now this is Q1 and Q2. Now since the polarity is opposite, I can say that when the charges flow over here, the total charge will be conserved, that is Q1 minus Q2 will be equal to same, which will be equal to C1 V1 plus over here, which will be equal to C1 plus C2 into V, where V is the final potential attained by the final potential that is common to both the capacitors. Now Q1 minus Q2 will be equal to 10 raised to minus 3, okay, 2 into 10 raised to minus 3 minus 1 into 10 raised to minus 3 will be equal to 10 raised to minus 3. C1 plus C2, so it will be equal to 6 into 10 raised to minus 6 is equal to V, okay. So total potential over here will be equal to 1000 divided by 6, which will be equal to 500 by 3 volt, okay. It will be equal to 500 by 3 volt. This is the final common potential attained between them. So option number A is correct, option number B is incorrect, okay. The second thing we have to find out is the loss of energy. The second thing we have to find out is the loss of energy, okay, or the ratio of the energy, okay. So initial energy in the first case will be equal to half Q1 square divided by C and by C1 plus half Q2 square divided by C2, okay, and the final energy can be written as half into C1 plus C2 into V square, okay. V is the common potential. We have to find out the ratio of the final to the initial energy. So U2 by U1 will be equal to, half will be cancelled out, it will be equal to Q1 square divided by C1 plus Q2 square divided by C2 divided by C1 plus C2 into V square, okay. Now Q1 square is equal to, Q1 is itself equal to, Q1 is given as 2 into 10 raised to minus 3 and Q2 is given as 1 into 10 raised to minus 3. So 2 into 10 raised to minus 3 the whole square, okay, divided by the original capacitance is 4 plus Q2 over here is equal to 1 into 10 raised to minus 3 the whole square divided by 2 is equal to C1 plus C2, that is equal to 4 plus 2, which is equal to 6 into 10 raised to minus 6 into V square. So V square will be equal to 25 into 10 raised to 4 divided by 9, okay, 25 into 10 raised to 4 divided by 9. This is the ratio of the initial to the final energies, okay. This is the ratio of the initial to the final energies over here, okay. So basically when I calculate this value, it will be equal to 4 plus 4 by 4, which is equal to 1, okay, 4 by 4 which is equal to 1 over here, okay, plus 1 by it will be equal to 1 by 2, okay, which is equal to 0.5 divided by, okay, divided by 6 into 25, which is equal to 150, okay, which over here is equal to 150 into, okay, into, it will be equal to, into over here, okay, into 1 by 9, okay. So 1.5 1 by 9, okay, when I calculate the value, the ratio will be equal to 9:1, okay. The initial ratio over here will be equal to 9:1, okay. So the ratio of the, or 1:9, or basically it will be equal to 1:9, okay. I have found out final by initial, okay. Over here I have found out final, initial by final. So final by initial, this will give me the ratio, 9:1, okay. This will give me the ratio 9:1, and this is initial by final, okay. So final by initial will be equal to 1:9, okay. So this will be the ratio of the energies developed, this will be the ratio of the energies developed across both the capacitors, okay. So over here this will be the final answer, which is equal to 1:9, which is equal to option number C. So the correct answers are A and C.